The solution of the first one is the solution of the first one is C. C it is C. As while you will be plotting the graph, you will be getting a graph like this, and the graph is cutting at two junctions. That is here, and this point is you will be getting this point as 1 comma 0 while solving, and this point you will be getting over here as 0 comma 3, and this point is 0 comma 1. So while solving, this shade is going this side, so that's why there is no feasible region is this, because the graph is not bounded. So answer of the first is C. This shade is going this side, so that's why there is no. For the second one the answer is D. Second answer is this shade is going this side, so that's why second answer is D. The answer is D over the second here. The second one the answer is D. Second answer is this shade is going this side, so that's why second answer is D. The answer is D over the second here. Answer is D over here. The graph is cutting at two junctions like this. It is this is the junction over here. This junction is this side 3 comma 0, and if you take this junction is what 0 comma 5 you are getting. This is over here we will be getting 0 comma 2. The graph is cutting at two junctions like this. It is this is your feasible region is this one. This junction is enclosed between the line 2x plus 3y equals to 6, and it is towards origin. So answer is D. The graph is cutting at two junctions like this. It is the feasible region is this one. Junction is enclosed between the line 2x plus 3y equals to 6, and it is towards origin. So answer is D. It is obvious. Third answer is B. Because the intermediate solution of the constant must be checked by substituting back them. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4. It is obvious. For the constant is B. Which of the one? Okay. So you need to plot this graph, because the intermediate solution of the constant must be checked by substituting back them. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4. It is obvious. For the constant is B. Which is the point you'll be getting as you need to plot this graph, the intermediate solution to constant must be checked by substituting back then. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4, the answer for the answer is B, which is the point we will be getting as you need to plot this graph. The intermediate solution to constant must be checked by substituting back then. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4, the answer for the answer is B, which is the point we will be getting as you need to plot this graph. The intermediate solution to constant must be checked by substituting back then. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4, the answer for the answer is B, which is the point we will be getting as you need to plot this graph. The intermediate solution to constant must be checked by substituting back then. So obviously you're going to substitute in the constant equation. Line 2x plus 3y equals to 6, and it is towards origin. So answer is D. Question number 4, the answer for the answer is B, which is the point we will be getting as you need to plot this graph. The intermediate solution to constant must be checked by substituting back then. So now is it clear? The voice is clear or not? Okay, we'll start with again the no, no, it must be clear. Okay, so we'll start with the next one. The question number 5 is question number 5 says the basic solution is called non-degenerate. Question number 5 I'm talking. The basic solution is called non-degenerate if none of the basic values is 0. So this is simple basic fundamental. It's a fundamental concept, and the answer for this is B. None of the basic variables is 0. Okay, now for your question number one is over. Okay, your sixth question is okay. If the number of available constant is 3 and the number of parameter to be optimized is 4, um, then the constants, obviously the constants are short in number. So your answer has to be B. The number of available constant is 3. The constant is 3 and number of parameters to optimize. So basically the answer is what B. The constants are short in number. Sixth is B. Sixth is B. I repeat, question number 6 is B. Okay, coming to the seventh one. Seventh is the solution set of the constants x plus 2y is greater than equals to 11. 4x plus 3y, okay, includes this point. Okay, I'll plot the graph, just wait. Question number 7. This is seventh one. The seventh graph, there are three lines in this. So your graph is gonna be like this, and one more line is gonna be the here it will be cutting. So basically, this line is your, you'll be getting over here as 0 and 15 by 2 you'll be getting. And yeah, I mean, your constants, your shaded part is going to be this line. So obviously your the solution sets involves 3 comma 4 in this. 3 comma 4 is there in this. So solution set involves 3 comma 4. 3 comma 4 is there in this. Okay, just wait. I'm coming to your fourth answer. Let me read the question of the fourth one. The point is outside. Kindly go through the video. You'll be getting to know. You'll get to know about that. The point is outside. Like this, you'll be getting the graph. Three lines are there. This is first line. The second line and the third line you'll be getting like this. Third line over here, and this point where it. I mean, your 2000 comma 0 is over here. This is 2000 comma 0 is over here because your feasible region is this. This is your feasible region for the 3 points. This is your feasible region. So 2000 comma 0 is outside. So fourth answer has to be D. Okay. Your eighth is your seventh answer is C. Eighth is A. Ninth is D. Your seventh is C. Seven goes as C. This is the solution of the seventh one. This one. The region is like this. So obviously this point, this is a shaded region. Over here, your 3 comma 4 is being included in this part. 8 is A. It is going away from the origin. 8 is A. are checking that ninth answer is ah again the ninth is the fundamental concept actually. Ninth is the physical region of LPP belongs to it's the physical solution of LPP belongs to the first quadrant because see for the ninth one the physical solution of the LPP belongs to the options are being given first and second quadrant. When you are taking the second quadrant in second quadrant you will be getting the negative values. Even in the third quadrant that is also the same thing or negative values will be there. Second quadrant again the negative values. Only the first quadrant because your constants that is x1 and x2 it is always it has to be what greater than equals to 0. So that's why the answer has to be what D. The tenth one says the position of the points O00 P2 in the region of graph okay will be okay you need to plot this one. I'll plot it off. Just wait. 10th. 10th is, if I'll plot it, it goes like this. The graph is like this. So this is, okay, just wait. 10th. This is 5 by 2 comma 0 you'll be getting over here. And this is, over here you'll be getting 0 comma minus 5 by 3. And this is your origin part. So your shade is going towards the origin. The answer has to be 10th answer has to be what? A. Has to be A. Yeah. 0 is, see, you can check it. Origin is inside and P is outside. You can check it. This is the origin. This is what inside over here. And your point P is what outside over here. So, 10th is A. So 10th is A. Okay. Come to the 11th one. 11th answer says 11th is the true statement of the graph of an equation 3x plus 2y is less than equals to 6 x plus 4y is greater than equals to 20 is 10th. Actually, you'll be getting a parallel line over here because the equation says, yeah, the graph is disjoint. The option has to be what A for the 11th one. Check it out. You're getting a 11th one is 11th is what you're getting to that is 3x plus 2y equals to this is what equals to 6 and the other equality you're getting as 6x plus 4y equals to 20. If we take it upon this is 2 times this is again 2 times so this is the graph is disjoint and they are parallel actually. So 11th is A. 11th is A. The shortcut for this is what 11th is A because parallel and they are going one is going the both are going one is going towards the origin and other is going away from the origin. So the one 3x plus 2y is less than equals to 6 is going towards the origin because it is less than equals to 6 and the other one 6x plus 4y is greater than equals to 20 that is greater than 0 is what greater than equals to 20. So obviously that is false, that's why it is going away from the origin. So 11th is A. 11th is A. 11th is A. 12 to 15 is asking. Okay, I'm coming to the 12th one. Your 12th answer is 12th question. Okay. The vertex of the common graph of inequality is 2x plus y is greater than equals to 2 and x minus y is less than equals to 3 is your 12th answer is, you can check this out. 12th answer is, yeah, it is. The graph is going for 2x plus y equals to 2. This graph is going like this, and x minus y is what equals to 3. So this is the shaded part over here. This is the shaded part. So answer is B for this, for the 12th one. Come to 13th one. 13th, your question says, 13th is the vertex of bounded region of inequality is x is greater than 0. Okay, your y is being not given over here. For the 13th, your y is not being given over here. So, okay, so if we take this 13th is, if we'll draw this graph 2x plus y, the region is like this. The line is like this for the 2x plus y, and this is x plus 2y equals to 0. When we plot the graph, this is the region, and the answer is D for this, for the 13th. Come to the 14th part. 14th, when you will solve this 2x plus 3y equals to 0, x plus 4y equals to 4, you will be getting x as 12 by 5 and y as 2 by 5. X as 12 by 5 and y as 2 by 5. Now you try to plot this graph. So when you're plotting these two lines, x plus 4y equals to xy plus 4y equals to 4 and 2x plus 3y equals to 6. So this is a shade actually. This is a shade it is going. This is a shade. One of the shade. Sorry, this is the line over here. It is going, and the other line is going over here. And the graph. This is my feasible region, and it is both are towards the origin. So uh, yeah. So that's why my vertex is 12 by 5 and 2 by 5 is the vertex. Um, this is this is the vertex. This is the vertex over here. This is vertex 12 by 5 and this is 2 by 5 you will be getting. 12 by 5 and 2 by 5 for 14th one. Come to the 15th part. 15th. Okay, the 15th goes. Let me read the question. The 15th question says. Just 1 minute, I'm reading the question. The 15th is a vertex of visible region by linear constants. Okay, two lines are being given. If we'll analyze the question, one is 3x plus 4y is less than equals to 18 and the other is 2x plus 3y is greater than equals to 3. So the vertex of feasible region, you need to find the feasible region for this. So 15th, when you're plotting these two lines, you'll be getting 3x plus 4y is equals to 18 and the other line is what, 2x plus 4y equals to 3. So answer is D for the 15th one. For the 15th it is D. None of these. Because see your 0 comma 2 is not there. 0 comma 2, 4.8 comma 0 is also not there. 0 comma 3 is also not there. So basically none of these is the answer for this one. For the 16th one. No, for the 15th one, sorry. For 16th one. For 16th one, read the question. The question says in which quadrant the bounded region of the inequality is x plus y is less than equals to 1 and x minus y is less than equals to 1 is situated. Okay, good question. If you're plotting this graph, suppose you'll plot this graph x plus y is equals to 1 and x minus, this is the graph you'll be getting over here. This is the graph. And both are, one is what, okay, both are less than equals to 1. So both are less than equals to 1. See, you'll plot it x minus x plus 1. x plus 1. Mm, X plus y equals to 1. So divide by 1 over here. So it is cutting at 1 comma 0 and 0 comma 1. The other part is x minus y is okay, x minus y. So other will cut at minus 1, minus 1, 0 comma minus 1, and okay, and 1 comma 0, 1 comma 0. So this is the part over. This has been connected over here. The line is going like this. So both are towards the origin. So this will go like this line, and this is also towards origin. So this will go like this. So basically, all the four quadrants are involved over here. So for the 16th, your answer is D. Come to the 17th one. Um, 17th, your answer. The necessary for okay, the necessary condition for the third region. Okay, third region. Obviously, it is obvious. Your answer has to be what B. Um, X is less than 0 and Y is also less than 0. For 18th is A. For 18th is A. I repeat, 18th is A. 19th is again a fundamental concept because the value of the objective function is maximum under linear constants. Um, the it will be maximum only when the vertex is maximum distance from origin, and how long how the points is far from your origin, that is 0 0. It depends on that. So your objective function will be maximum only under that constant. For 20th, come to the 20th one. Your 20th says the region represented by 2x plus 3y minus 5 is less than okay. Okay, so this is only bounded in the first region. 2x plus 3y. If you plot this line, so you'll be getting this like this type of graph, and it is bounded in this region. So your 20th answer is B. Come to 21st one. 21st says the region represented by the inequation system x and y is greater than equals to 0, y is less than equals to 6, and x plus y is less than equals to okay, less than equals to 3. Okay. Again, if you're plotting this graph, this is y equals to 6. This is line y equals to 6, and this is another line, that is what x plus y equals to 3. And obviously, when you're saying x plus y equals to 3, for the 21st I'm talking, say again, Brijesh, this is for you. Um, okay, I'm plotting this. Okay, this was uh, y equals to. If you know this, mm, this is our x and this is our y. When we plot, this is y equals to b, and when we plot downward, this is y equals to what? Minus b, I call. So according to the same this theory, y equals to 6, I can plot it easily. Yeah. Okay, y equals to 6 will be over here. Y equals to 6. This I'm talking for 21st one. 21st question number 1. 21st question. Y equals to 6 and x will cut at 3 and y will cut at 3. Okay. So this is cutting at 3 and y is also cutting at 3. The line will go like this. The common shaded part for both will be this one, this region, because both are going towards the origin. Both are going towards the origin. Yes. So both are going towards the origin. So your answer is what? C for this one. C. Bounded in the first quadrant because it will not go down. Your 22nd answer is B. Okay, just wait. I'm coming to the 18th one. Question says, for the following feasible region, the linear constants are. So if you see properly, na, the option A, x is greater than equals to 0, y is greater than 0. That means what it is obviously has to be the first quadrant. I mean, all the cases it is being first quadrant. If you see 3x plus 2y is greater than equals to 12, this is also going away from the origin. X plus 3y is greater than equals to 11. This is also going towards, away from the origin. Both are going away from the origin for the first one. And if you see the graph also, this is also going away from the origin. I mean, for both the graph, it is going away from the origin. The option for the option A, it is almost correct. When you are checking the B option, that is 3x plus 2y is less than equals to 12. It is less than equals to 12 means what for this line, it has to be towards origin. I mean, it has to come towards downside. So, but the shade is being given towards upwards. So that's why the option B cannot be correct. Option C, when we are taking again the same thing, 3x plus 2y is less than equals to 12. So the shade for 3x plus 2y has to come down, but it is not coming down, it is going up. So that's why option C is also wrong. So only option A is correct for 18th one. Hopefully it is correct for you. Okay, 21st is over. Come to 22nd one. 22nd is your 22nd is B. The solution set of an equation 2x plus 3y is greater than equals to 5 is 2x plus y equals to 5. Open half but not containing the origin because it is strictly greater than 5. For question number 22nd, it is strictly greater than 5. That's why open half plane not containing the origin. Because 0, if you'll see this, 22nd, just wait, I'll draw it. 22nd, you are taking 2x plus, the question was uh, 2x plus y is greater than 5. Okay, 2x plus y is greater than 5. This is 2x plus y is greater than 5 you are taking. So 2x plus y. 2x plus y. I mean, both are going to be like this shade. I mean, it's not containing the origin for 22nd. Yeah. So 22nd is B. 23rd is also B. 23rd is also B. 23rd is also B. Hopefully it is correct. Um, Hopefully everyone is able to get it easily. If any doubt is there, you can post it in the live chat. 24th is A. See, if you'll check your 24th one, your 24th says the equation y minus x is less than equals to 0. 24th I'm talking. So this is the region. See the 24th one. Quite important sum for your JE. Y minus x, this is a region. This is a region. And it is less than equals to 0. So obviously if you're putting y and x value as 0 0, so 0 is less than equals to 0, falls away from the origin. So that's why for 24th the half plane that contains positive x-axis, because it is containing towards this side. This is the positive axis where my cursor is going. This side it is my positive x-axis. That's why option A has to be correct for the 24th. 25th is 25th. Okay, objective function of LPP is what? Obviously you have to optimize that. For 25th it is optimized, you have to optimize it. Okay, just wait, I'll open the questions. 25th, because we always optimize the LPP, that is Z value we always optimize. 25th. 26th one, the check your 26th question. The optimal value of objective function is attained at the points. What are the points we attain? Only the corner points we are checking, I think. So for 26, the given by the corner points of the feasible region, where we are when we are taking the feasible region or shaded region, and we are only checking the corner points, and we put the points in Z. The corner points we put in Z to get the maximum or minimum value. So that's why the answer has to be what? C for 26. Come to 27th one. 27th is, sorry, uh, 27th. The objective function Z is equals to 4x plus 3y can be maximized subject to constant this. Okay, this you need to plot it properly. And this you need to plot it properly. And hmm, you plot it and then post it to me. I'll get to know whether you have understood or not. Come to 28th one. If the constant is in a linear programming problems are changed, the problem has to be re-evaluated. Obvious it is. 28th one. The solution will be defined, and the objective function will be same. No need to modify. Z can be same. The change in constants cannot be ignored. So therefore, the problem has to be re-evaluated. Come to 29th one. Which of the following statement is correct? Every LPP admits an optimal solution. Mm, Incorrect. This is LPP admits a unique optimal solution. This is also incorrect. If a LPP admits two optimal solution, it has infinite number of optimal solutions. This is correct. So the set of feasible solution of LPP is not convex set. Okay. For 29th one, your option C is correct. This is quite important for your CT as well as JE also. 29th one, C. Come to 30th. The shaded region is represented by, okay, 29th. Um, See, for both the lines, it is coming towards the origin. So it is coming towards the origin. That means what? This also has to be what less than equals to zero, and this also has to be what less than equals to zero. For 30th, I'm talking. This also has to be less than equals to zero. So in the question, this also has to be less than equals to zero, and as well as this equation also has to be less than equals to zero. So the 30th, see the one in the option it is being given. This is greater than zero. This is greater than zero. That's why the option A is incorrect. Again, if you're checking the this also is what greater than equals to zero option. This is incorrect because both has to be less than equals to zero. Yeah. This is less than equals to zero, less than equals to zero, and x is greater than zero, y is greater than zero. So this is fulfilling all the condition. That's why the option C has to be correct. Option D we are checking. So option C is correct for this one. Option D is 2x plus 5y is less than equals to 80. This is correct. X plus 2y is less than equals to 20. This is also correct. But the thing is, x is less than 0 and y is less than 0. You cannot take x is less than 0 and y is less than 0, because when you're taking x is less than 0, option D, when you're considering option D, x is less than 0 and y is less than 0, that means what you are taking towards the negative axis. But it is the shade is in the positive axis. That's why the option C has to be correct. That is x is greater than equals to 0 and y is what? Greater than equals to 0. So we'll stop till here on question number 30th. Tomorrow we'll discuss further 30th question in the morning sessions or in the afternoon session. Then again we'll start with the application of derivatives. Thank you. Thanks a lot.